Uh, just I will repeat once again from the type 1 since many were absent here. So looking into the diagram, the type 1 is very simple in a construction type where your ambient air will be passes, or the hot air will be passes from a glazed or unglazed solar collector which is shown there. Okay, and this air will passes directly to the rooms to provide ventilation and heating. So this kind of method or this kind of type 1 will be used in the application where vacation cottages or large industrial buildings where we require adequate ventilation. In that cases we can go for a type 1. In the type 2, it's nothing but a closed path type where the circulate it will circulate room air back to my collector. Okay, circulate room air to the collector. You can see in the diagram the type 2, so where air is going back. So here the heat air rises to the thermal storage ceiling. So obviously it's a natural phenomenon. The heat air will rise to the thermal ceiling, which will be conveyed back into the room. So this system usually natural convection as well as well suited for the apartment buildings. Okay, where I can make use of that hot air at the ceiling and the cool air will be passed once again back to my collector. So this is how the closed path will be done in a type 2 system. And coming to type 3, it's a collector shell collector type. So where we can see there is something like a passage or a duct we can say where this hot air will be, or the air which will be passed from the solar collector to the building here. So this is particularly suited for your insulated buildings where collectors heated air will pass through the cavity between the outer insulated wall and the inner insulated wall. So it will be like a cavity type where it will be passage where air can easily flow, the heat air can flow into that. This creates a buffer that considerably reduce heat loss in a building. So by passing a heat only in this passage, I can avoid the heat wastage, or which will be loss of heat can be avoided. That is my type 3. This will be mainly used for my apartment buildings. And coming to the fourth one, where type 4, that is your classical solar air heating system. So this is a normal thing where we have a collector where we store the energy and will go back to the collector. So if you look at that, in the floor we have a passage. In the floor of the building we will be having a passage or a duct where I can store this solar energy and I can make use for a longer run also. Okay. So usually this classical solar heating system is very commonly used system which collects heated air in the and circulate through a channel in the floor or in the wall also. Okay, in the floor or in wall also. So whatever the heat is radiated into the room with a time delay of 4 to 6 hours, we can stay this energy over there because of I'm storing over somewhere else. The advantage of this system consists of large radiation surface which provides a comfortable climate because of it stays this hot or uh, space cooling, so it can stay for longer duration. That's the one advantage here. And this system with forced ventilation fan provides the best efficiency and thermal output. If I have an additional fan which we connect here so that I can suck the air or I can uh, remove the air from the ducts. So by using this, what happen, I can improve the overall efficiency and the thermal output will be very good here. So this may be used for your large buildings with a large surfaces which serves as a radiation sources. We can go for a very large building. Coming to the type 5, once again it's a collector, storage collector, but if you look at that, not only it's a collector, it is something similar to the first one. Okay, so in this it's an advanced version of type 4 we can say. Okay, where just we store the energy and it will go, whereas here whatever the energy stored here, it will go to the entire space or the building and it can come back once again. There will be option where I can return this energy back to the collector or return back to the duct. So that is an advanced version of a type 4 here. Okay. So here the room air is circulated through a space channel or a separate channel of the storage, and heat can be stored for a long period of time. So this heat can be once again stored for a long period of time as compared to the type 4, and we can release whenever it is needed. I can store and I can release whenever it is needed. However, this type is used very rarely because of the investment cost will be very high, because I need to have some additional thing there where whenever I require the heat I can release the heat and I can take back that once again to the storage part. So some additional equipment will be involved, hence the cost will be high in a type 5. And coming to the type 6, it is a collector, heat exchanger collector. I am using a auxiliary heat exchanger here. Okay, apart from the solar, I am making use of something else so that I can heat air here. It's a combines of a solar collector and a heat exchanger. Okay, we can say hybrid system, which has a solar collector and we have a heat exchanger. So where the conventional heating system will be taken place through a common radiator and a floor or a wall, heating components may be used here. So I can transfer the energy which will be uh, obtained from your heat exchange radiator, that also can be given to my building. So this system can also provide domestic hot water also, because I'm using a heat exchanger here. I can pass a fluid into the heat exchanger so that your water also will get heat. That is also one advantage when I'm using this one. And once again, this will be best suited for the building in which heat has to be transported over a long distance, because your heat exchanger will be somewhere else and your solar collectors and the building is somewhere else. I need to transport your heat exchanger energy to the building. So wherever the transport place will take in a long distance, in that cases we can adopt the type 6 method. So these are the different types of solar space cooling system. Depend upon the application, depend upon the building, it has been categorized. So next we'll move on to the next topic,